And as you already know, I like to throw in some application problems and just walk you through these to show you that doing a word problem does not have to be a scary, awful thing. So let's look at what these look like with perimeter. So this first one, a rectangular room, is 12.5 feet wide and 14 feet long. What is the perimeter of the room? All right, this isn't a hard problem. With his word problems in general, I try to draw as much as I can. I think that it's really important to get a sense of what the problem looks like. So you've got your rectangular room, right? That means you've got right angles in the corners. And we'll say that this is 12.5 feet right here, and we'll say that this is 14 feet. So these are our dimensions, all right? And we're finding the perimeter. So that means that if I start here and I walk all the way around the room, I'll do this with another color. I go there, I go there, I go there, and I go there, right? And so we just want to add up all those lengths, see what we get. Well, if I start here and I go this way, right? First one's going to be 14. Then I'm going to go up this way. That's going to give me 12.5. I'm going to put it as a decimal. And this way will give me 14. And then coming back to where we started from is another 12.5. And if you're thinking, why did he do that? Why didn't he just multiply him by 2? If this would have just been me doing that, that's exactly what I would have done. So I'm glad you're thinking that. So 14 and 14 is 28. And then 12.5 and 12.5 is conveniently enough 25. And then you go 28 plus 25. So 28 plus 25. And yes, I can do this in my head, but I'm just trying to be nice. Gives you 53. All right, and then our unit is feet. So 53 feet is what the perimeter of the room is. And where this is useful is supposing you wanted to put baseboard molding along this room, or supposing you were wiring up speakers or something like that, where you needed to figure out lengths of walls and things like that. So it's using perimeter and measures that are related to perimeter are actually very real world, and you will use them. All right, the tire for a 10-speed bicycle has a diameter of 27 inches. Find the distance traveled in 10 rotations of the tire. So if you think about what a bike tire looks like, and you got your hub, and that nut goes over the axle, and you got all your spokes that come out, right? And so what they're saying, right, is that it has a diameter of 27 inches. And most real world measures of circles are diameters, because they're much easier to find, because a lot of things don't have a perfect center to them. So you would say this, right, is 27 inches. And we're going to use that double hash mark to denote inches. It says, find the distance traveled in 10 rotations of the tire. So that means that as the tire turns and goes this way, right, you would go and it would start here, right? And then you would go around. Oops, that's bad. Let's do a different color. Start here, and it would go around. And that would be one time around, and they want to know what that is, 10 rotations. So that would basically be one of those around is just a circumference, right? So we would need 10 of those. I'm going to go to a color that you can see better. So we would say we need 10 circumferences, right, is what we need to know. So let's find one. So the circumference is 2 times pi times r. So it's 2 times pi, and my radius is going to be half of my diameter. And so if the diameter is equal to 27, the radius is 27 divided by 2, which is 13.5. So it's 2 pi times 13.5, and then in circular logic, 13.5 times 2 gives me 27 pi. All right. So sometimes maybe it would make more sense if you just did pi d, but like I said, I like to just use what I'm used to. So 27 pi, you take your calculator, you go 27 times pi, you get 84.8. And because we were talking about distance, I am going to go out to hundredths on this one to be a little more exact. So 84.82 was what we had. So 84.82 inches is what the circumference of this tire is. And then we will take that and we recognize that, well, it's going to go 10 times around, right? So how far do you go in, how do you go far, how far do you go in 10 rotations? Sorry, I don't know why that was so hard to say. So if you multiply 84.82 times 10, whenever you multiply by a power of 10, you can just move the decimal to in the respective way you want to go, however many zeros you have. So I have 1 0, so I'm going to move the decimal one place. So it's 848.2 inches is how far we'll travel. And then if you wanted to be really fancy, you could say, okay, let's divide this by 12 to see how many feet that is. I'm personally interested in this. And of course, in doing that, I forgot. So 848.2. All right. 848.2 divided by 12 gives me, so it would be 70 feet. So you go, I don't know what I'm doing. You would go 70 and feet, right? And then you do 70 times 12, right? So that would be 840, and then you'd have 8.2, and then 8.2 inches. So 70 feet, 8.2 inches, or they would do it like this: 70 feet, 8.2 inches. Okay, and 0.2 inches is 1/5 of an inch, and that's not really a thing, so we'll just leave it as a decimal like that. So that's how far you'd go. And that's, you think about it, you just go 10 feet or 10 times around and you go 70 feet. That's pretty far. All right, good luck.